Today we're going to talk about compounding interest. Part 1. As an enterprising young mathematician, you know that your superior knowledge of mathematics will help you make better decisions about all kinds of things in your life. One important area is money. So you've been contemplating the world and wondering how you can maximize the money that you make in your savings account. You're young and you haven't saved much money yet. As a matter of fact, you only have $100, but you really want to make the best of it. You like the idea of compounding interest, meaning that the bank pays you interest on all the money in your savings account, including whatever interest that they had previously paid you. This sounds like a very good deal. You even remember that the formula for compounding interest is exponential. Let's see, it is a equals P times 1 plus R over N to the NT power. So A stands for the amount of money in the account at time T. P is the principal or original amount you invested. T is the number of years. R is the annual interest rate, and we use a decimal. And N stands for the number of compounding periods per each year. So for question 1, it says, if your savings account pays a generous 5% per year and is compounded only once each year, how much money would be in the account at the end of 1 year? So I always like to rewrite the formula each time because every time if you keep rewriting it over and over, it's kind of like when you learned how to spell, the more you write something down, the more you'll keep it to memory. So for this one, our P, which is our principal, we started off with, it told us above $100. So that was up here when they were talking about um, how much you have. So then it says our rate is equal to 5% per year. So as a decimal, that would be 0.05. And N is equal to once per year. So 1. And T is equal to, it says how much at the end of 1 year, so 1 year. So A is equal to, so the amount is 100 times 1 plus 0.05 divided by 1 to the 1 times 1. So A is equal to 100 times 1.05, because that's just divided by 1 to the first power. So 100 times 1.05 means the amount would be $105 at the end of 1 year. So question 2 says, how much will be in the account at the end of 20 years? So A would be equal to 100 times 1 plus 0.05 divided by 1 to the 1 times 20. And then you could go ahead and plug this into your calculator. So make sure you're plugging this correctly into your calculator. That's usually the place where students make their mistake. So this one's easy because we're just dividing by 1, but 100 times 1 plus 0.05 divided by 1 to the power of 1 times 20. And if you have an older calculator, you want to make sure to put that exponent in parentheses. Since it's newer, notice it just automatically puts it as an exponent for me, so that's nice. And enter, and we get to $265, and of course we're rounding to the nearest hundredth, so 2 decimals, and 33 cents. Okay, let's go to the next page. It seems like the more compounding periods in the year, the more money that you should make. The question is, does it make a big difference? Compare the amount of money that you would have after 20 years if it is compounded twice each year, semi-annually, 4 times per year, quarterly, and 12 times per year, which is monthly. So for this one, semi-annually, we know N is 2 because that's twice per year, quarterly is 4, and monthly is 12. So, of course, we want to write down the formula. A is equal to P times 1 plus R over N to the NT power. And so in this case, P is still 100. R is equal to still 0.05. N now is equal to 2, and T, again, it says after 20 years, so is equal to 20. So when I plug that in, I get A is equal to 100 times 1 plus 0.05 divided by 2 now, to the 2 times 20. So again, in our calculator, 100 times 1 plus 0.05 divided by now 2 to the power of, and again, if you have an older calculator, make sure you do parentheses, 2 times 20. Newer calculators, it's not necessary. So $268.51 when you round. So go ahead and pause the video and do the next two on your own. When you're done, you can unpause to check your work. All right, so for this one, P is equal to 100 still, R is equal to 0.05, N now equals 4, and T is equal to 20. So A is equal to 100 times 1 plus 0.05 divided by 2 to the, or divided by 4, sorry, because we're doing compounding quarterly, to the 4 times 20. And when you plug this into your calculator, you should get $270.15. And for the last one, P equals 100, R is still 0.05, N now equals 12, T is still equal to 20, so A is equal to 100 times 1 plus 0.05 divided by 12 to the 12 times 20, and plug that into your calculator and you should get $271.26. So the next question says we want to, and this one's going to be a little different, find the principal needed to get each amount. So now we're solving for P. So for this one, it says to get $500 after 5 years at 6% compounded daily. So A is equal to P times 1 plus R over N to the NT power. So we want $500 as our final amount, so 500. And it told us that we're solving for P. We don't know, we're finding the principal. R is equal to 6%, so 0.06. And then we have N is equal to 365 because it's compounded daily and there's 365 days in a year. And T is equal to 5 years. So A is equal to, sorry, not A, but 500 is equal to P times 1 plus R, which is 0.06, divided by N, 365, to the 365 times 5. So the question is, how do we solve for P? If you notice, P is not as an exponent, it's just being multiplied by all of this, and this is just doesn't have any variables in it, it's just numerical. So if you have something being multiplied by the variable, how do you solve? You divide it. So that means P is equal to 500 divided by 1 plus 0.06 divided by 365, all to the 365 times 5. So in my calculator, this is again making sure you're plugging in correctly. So 500 divided by parentheses 1 plus 0.06 divided by 365, and that is all to the power of 365 times 5. If you have an older calculator, you want to put double a parenthesis here and a double parenthesis after the division symbol. So that gives us $370.42. Here we go. And I actually want to go back up here for a second because I didn't answer this question. It says It seems like the more compounding periods, the more money that you should make. The question is, does it make a big difference? So notice that we did make more money each time we compounded it. But as you are compounding it more and more, you're going to make more money, but the difference isn't quite as big as going from like 2 to 12, which was a little bit bigger. So you guys go ahead and see if you can do 5 on your own. When you're done, unpause it, and we'll go ahead and check our work. So again, A is equal to P times 1 plus R over N to the NT power. So for this one, the amount is equal to 200. We're solving for P. And R is equal to 0.085. T is equal to 10. And compounded monthly, so N is equal to 12. So 200 equals P times 1 plus 0.085 divided by 12 to the 12 times 10 power. And plug that into your calculator and you should get $85.74. So now the next question says, find how much time is needed to save each amount. So now we're looking to solve for time. If Ellie has $500 to invest at 10% compounded monthly, how long before she has $600? So again, just practice writing down your formula. So our amount, it tells us is 600 because that's how much we want, how long will be before she has the $600. The starting amount is $500. R is equal to 10%, so 0.10. N compounded monthly is equal to 12, and T is now what we're solving for. So we get 600 equals 500 times 1 plus 0.10 divided by 12 to the 12t. So keep in mind when you're solving for a variable, you're doing PEMDAS backwards. So I need to solve for t, which is an exponent. So remember, exponents are over here, so that means first, before I can even get to here, I want to get rid of things that are added or subtracted, which I don't have on the outside of the exponent, multiplied or divided, which I have this right here, that 500, so I would want to first divide that out. So divide by 500. So 600 divided by 500 is 1.2, and that's equal to 1 plus 0.10 over 12 to the 12t. If it doesn't give you a nice decimal, then just leave it in fraction form so that you get a more exact answer. Because the more rounding you do, the more rounding error you're going to have. And so now we can do our exponent. So now I have a variable as an exponent, and we just spent a whole bunch of time in this last unit talking about how to solve a variable with an exponent. So take a moment to see if you can remember, what do I do in order to solve for a variable exponent? So remember, we can go ahead and, since this is the base with the exponent, rewrite this in logarithmic form. So this is the log, and the base is 1 plus 0.10 divided by 12 of, the argument is 1.2, is equal to the exponent 12t. And then the last step would be to divide both sides by 12 to solve for t. And then you'd have to plug this into your calculator. So in my calculator, go to math. We have that log base button. So that is 1 plus 0.1 divided by 12. And then in here we have 1.2, or 6/5. And then I'm going to hit enter and then divide that answer by 12. So 1.83 looks like years. And so that gives us our time. And of course you could check your work by plugging that in for your time and see does that equal approximately close to 600. It's not going to be quite equal because we rounded our answer. All right, question 7 says Ryan wants to save $6,000 to buy a motorcycle. He deposits $4,500 into his account that is compounded quarterly at 9%. How long will it take him to save enough money to buy the motorcycle? So go ahead and pause your video and do this problem on your own. When you're done, you can unpause it. So for this, A is equal to P times 1 plus R over N to the NT power. So our amount that we want is 6,000. P is equal to 4,500. R is equal to 9%, so 0.09. N is equal to compounding it quarterly, so 4. And T is what we're solving for. So 6,000 is equal to 4,500 times 1 plus 0.09 divided by 4 to the 4t power. So again, we're solving for the variable exponent. First thing we want to get rid of is that 4,500. So to get your decimal, you can hit the math fraction key. So 6,000 divided by 4,500, and then hit the math fraction key. So 4/3, because it's 6 over 45. So just in case if you didn't know. So 4/3 is how you can get that. And we have 1 plus 0.09 divided by 4 to the 4t power. Now I have the base with the exponent. I can go ahead and write this in logarithmic form. So the log of 1, whenever we write this, the log of 1 plus 0.09 divided by 4. The argument is 4/3, and that is equal to the variable exponent with the 4 times t. And then divide by both sides by 4, and t is equal to, so we get math log base, what's it, 1 plus 0.09 divided by 4, and then 4/3, enter, divided by 4, and so 3.23, so t is equal to 3.23 years. So that's how long it would take to save enough money to buy the motorcycle. So for the next problem, it says, it turns out that the value you're going to be compounding the problem is 100 times a very famous irrational number named E. Because E is irrational, it's a terminal, non-repeating decimal like the number pi. The first few digits of E are 2.71828, etc. Like pi, E is a number that occurs in mathematics of many of the real-world situations, including exponential growth. One of the formulas using E results from the thinking that you just did about the compound interest. So it can be shown that the amount of money in a savings account where the money is compounding continuously is given by this formula right here. So the more and more you compound something, the more and more it approaches that value of E. And so we get this formula instead. And the key words for using this formula are the fact that it says compounded continuously. If you see those words in a problem, that is the key to tell you that you are going to use this formula. So for this, A is still the amount of money in the account after any time t. P is still the principal or original amount. R is the annual interest rate, again as a decimal, and T is the number of years. So recall, remember we had y equals e to the x power. We just talked about this in the other lesson. And the inverse of this, you switch the x and y, so x is equal to e to the y power. How do you solve for a variable exponent? You use logs. So log base e of x is equal to the variable exponent y. And remember that log base e is also written as the natural log of x equals y. Those mean the same thing. So remember, this is just the base of e. So we already talked about that. So for e, we know how to use it in our calculator, and we know, again, we can use the natural log, or you can use log base e. It doesn't really matter. So looking at the next question, it says how much money will be in your savings account after 10 years with an initial investment of $500 and interest rate of 3% compounded continuously. So those are the key words to tell me that I am using that formula. So A is equal to PE to the RT power. P is equal to 500. T, it says, was 10. R is 3%, so 0.03. And E, we know, is equal to a number using our calculator. So for this, we have A is equal to 500. You don't plug anything in for E. Use your calculator to get the value of E. 0.03 times 10. And so on my calculator, we have 500. Recall that you can either hit second in the division symbol or second and the ln for the power. It doesn't really matter. I always use the division symbol and then the caret key if I need a power. And that's to the 0.03 times 10. If you have an older calculator, again, make sure you put parentheses around the exponent. So $674.93. Question 9. How much money will be in your savings account after 20 years with an initial investment of $2,200 and an interest rate of 5%, interest compounded continuously? So go ahead and pause the video, do this one on your own. When you're done, you can unpause and check your work. So A equals PE to the RT power. P is equal to 2,200. R is equal to 0.05. T is equal to 20. And when you plug this into your calculator, you get 598, or excuse me, $5,980.22. All right, last problem. Mary has an initial investment of $8,000 with an interest rate of 10%. If the interest is compounded continuously, how long is the question will it take for her to save $12,000? So again, A equals PE to the RT power because of those key words. A is equal to 12,000. The initial investment P is equal to 8,000. R is equal to 10%, so 0.10. T is what we're solving for. So 12,000 is equal to 8,000 times e to the 0.1 times t. So we're solving for variable exponent. So PEMDAS backwards, you need to get rid of things multiplied by the base with the exponent first. So that 8,000. That gives us 1.5 is equal to e to the 0.1 t. Now I have a base with the exponent. I can go ahead and write this in log form, or you can use natural log. So if you use log, it would be log base e of 1.5 as the argument equals the variable with the exponent. It's 0.1 t. Or you could write natural log of 1.5 equals 0.1 t. Both are the same thing, divided by 0.1. And so t is equal to, I'm going to go ahead and use the natural log on my calculator because it's faster. So the natural log uses base e always of 1.5 and divide that by 0.1, which gives us 4.05 years. And again, even if you did use the log base of e, which is fine, notice you would still get the same answer, 4.05 years. for her to save that amount of money. And that's it for this lesson.